Good morning, students. How is it going on? I assume you have attended the last two lectures. Let's start with the third one, all right? Now, before we start, I'd like you to solve this question. What you need to do is pause the video, solve, and then resume. Now, those who have solved this question, congratulations. Those who have not, bear with me. Actually, those who have solved, they also bear with me. We are going to learn something new anyway. Let's start with the remainder theorem. We actually know that whenever we, let's say, divide 9 by 2, we get quotient as 4 and the remainder as 1. Now, 9 is the dividend, 2 is the divisor, 4 is the quotient, and 1 is the remainder. And in standard 5th or 6th, we have already done this, that whenever we used to divide, we used to check our division. What we used to do was we used to multiply the quotient and divisor with and add a remainder to it. So that is what remainder theorem is. But believe me, this is going to be helpful in your exams. Questions are asked on this concept. Let's see. A number when divided by 78 gives a quotient 280. We don't know the number, let that be x. So the divisor is 78, the quotient is 280, and the remainder is 0. Well, we won't write 0. Now the question states, let's divide the number by 65 and find the remainder. Now I can clearly see it is divisible by 13 and this is divisible by 5. So we can very clearly see that the number gets divided by 65 completely, and whenever such thing happens, the remainder is always 0. Pause the video, try to solve this and come back. Question states, on dividing 8, 6, 7, 5, 1, 2, 3. The quotient is 3, 3, 6, 1, 1. And the remainder is 3, 4, 8, 5. We do not know about the divisor. Anyway, we are supposed to solve this. What we'll do is move this to this side and subtract it. That will be 8, 3, 6, 4, 7, 6, 8. And over here it will be same as over here. Now what we are supposed to do is move the quotient to this side and supposed to divide. Although we could have used unit digit, but the problem over here is that the unit digit would be 8. 1 times 8 is 8, but we have 3 such options and we anyway don't wish to divide it completely. What we'll do is we'll try the divisibility of 3. As we can very clearly see that this is not divisible by 3. Why? Because 3, 3 and 6 would get cancelled, but the 2 won't. Let's check on this. What we'll do is we'll cancel the multiples of 3. 6 and 6 gets cancelled, 3 gets cancelled as well. 8 and 7 is 15 gets cancelled. 8 and 4 is 12 gets cancelled. So this is a multiple of 3. Answer needs to be multiple of 3. If we check in this, that is 13 and 16, not possible. This one might be, this ain't, and anyway we are not going to check for this because the unit digit is not 8. So the option B would be correct option. I guess you are understanding the concepts along with the approach which you need to have in exam. It is not just about learning the concepts. Now come back to the question which we discussed in the first minute of the class, this one. Number when divided by 899 gives remainder 63, and if the same number is divided by 29. In such questions, you will always be given 2 different divisors. You will always be given 2 different divisors, and our concepts arises from the same. Let's learn the concept. Whenever we are asked remainder, 2 divisor 1 and divisor 2 would be given. Now, there can be 2 different cases. Either divisor 1 is a multiple of divisor 2, or divisor 1 is not a multiple of divisor 2. For example, if you observe over in here, divisor 1 is a multiple of divisor 2. That's right, sir. Divisor 1 is not a multiple of divisor 2. In this case, yes, it is a multiple. This ain't a multiple. All right. So whenever we are clear that divisor 1 is a multiple of divisor 2, what we do is we assume the number to be equal to remainder. And if it is not a multiple of divisor 2, we say that remainder can't be determined. All right, remainder can't be determined. And this type of question is very rare in SSC exams, although there are a few. Let's try to learn this using some examples. We can see that the question states the number when divided by 899 gives remainder 63. So I'll write remainder over here is 63. If the same number is divided by 29, all right. Now we have two different divisors. D1 is 899 and D2 is 29. As we can very clearly see that 899 is a multiple of 29. We can say we'll assume the remainder itself to be the number, let the number be x. We are asked to divide x by 29, that is 63 by 29. That gives us a remainder of 58, that is 5. Option A is the right option. I hope you are understanding. Next question, very similar one. You can solve this. Pause the video seriously and try to solve this. You will be able to do that orally. Again, same type of question. We are given two divisors and this one is the remainder. We'll say if divisor 1 is a multiple of divisor 2, which it is, we'll assume the number to be the remainder itself. We are supposed to divide the number by 16, that is 48, and the remainder over here as well would be 5. Very simple questions, but tricky if you don't know the concept. Next question. Again, same thing. There are two divisors and a remainder. We'll write divisor 1 equals to 442 and divisor 2. Give me a second. All right. And divisor 2 to be 39. Now that is 390. That won't be a multiple. Over here, that won't be a multiple. If that is not a multiple, we cannot ever decide what the remainder would be. So we'll mark option D. All right. Next question. Question states when a number is divided by 14, so the divisor first is 14, it leaves a remainder 9. If the square of the same number is divided by 14, all right, but the second divisor as well is 14. Now obviously it is a multiple, right? It is a multiple. So we'll assume the number to be remainder itself. The question is you need to square the number. We'll square the number, that is 81, and now 81 is divided by 14. 81 is divided by 14. All right. If we cancel this, we'll get 70 and the remainder would be 11. So option A is the correct option. Next question. Now in this question as well, you can find that there are two different divisors. First one is 21 and the second one, it's the same divisor, so second one as well would be 21. Obviously it is a multiple, so we'll say that the number would be remainder itself, that is 13. Question states you are supposed to find thrice the square of number, that is 3x square. 3 times 13 square, that is 3 times 169, and you are supposed to divide it by 21 only. If you divide 3 by 21, you get 3 as remainder, and you divide 169 by 21, that would be 8 times 168, 1 as remainder. Multiply them, you get 3 as your remainder. So the correct option would be D, which is 3. Next question. Slightly tricky. Let's see. But based on the same concept. It says 7 divided a positive integer n. So our number is n and is divided by the first divisor, which is 7. Which one of the following numbers gives a remainder 0 when divided by 7? Okay, so the second divisor as well is 7. Obviously it is a multiple. Now if it is a multiple, we'll assume the number to be the remainder itself. Now what we'll do is we'll put the values over in here. We'll put the values. If we put the value 2 over here, it gets 4. Put the value 2 over here, it gets 7, that is minus 3, and that is 3. The only option which could be divided by 7 and would leave a remainder 0 would be option B. Very simple was that. Last question, I guess. When positive number x, y, z are divided by 31, alright, so divisor 1 is 31 and it is again divided by 31 only. Divisor 2 is 31. So the first one is a multiple of second, yes. The remainders are 17, 24 and 27. We'll assume the first number to be 17, second number to be 24y, and z third number to be 27. They said that 4x minus 2y plus 3z is supposed to be divided by 31. Let's try to find the value for this one. 4 times 17 minus 2 times 24 plus 3 times 27. That would be 68 minus 48 plus 81. 20, that would be 101. Now 101 is supposed to be divided by 31. If we divide 101 by 31, that would be 69. 93, my bad. 93, and the remainder would be 8, I'd say. So the correct option would be option B. I guess you guys understood this. Now, if you like the video, please do like it and comment if you wish for any suggestion. That would be highly appreciated. Meet you in the next class. Thank you.